Have you ever looked up at the night sky and wondered what those twinkling lights really are? They're not just distant diamonds. They're suns, just like our own, each with a dramatic story of birth, life, and death. Today, we're going on an epic journey across the cosmos to witness the incredible life cycle of stars. From glowing stellar nurseries to the most violent explosions in the universe. Get ready to see the heavens like never before. It all begins in the cold, dark, and vast expanses of space, in something called a giant molecular cloud. These aren't your typical fluffy white clouds. They are immense sprawling regions of gas and dust, hundreds of light years across. Think of them as cosmic nurseries. For millions of years, these clouds just drift. But then, something disturbs the peace, maybe the shockwave from a nearby supernova or the gravitational pull of a passing star. This disturbance causes pockets of the cloud to clump together. As these clumps gather more gas and dust, gravity takes over, pulling everything inward. It's like a cosmic snowball effect. The clump gets denser and denser, and the pressure at its core starts to skyrocket. This intense pressure generates incredible heat. The once cold clump of gas begins to glow, first in infrared light, and then in visible light. This glowing baby star is called a protostar. It's not quite a star yet, but it's on its way. This toddler phase can last for hundreds of thousands of years as the protostar continues to feed on the surrounding gas and dust, growing more massive and hotter. Finally, the moment of ignition arrives, when the core of the protostar reaches a staggering temperature of about 15 million degrees Celsius. A process called nuclear fusion begins. This is the true birth of a star. In the core, hydrogen atoms are forced together under immense pressure, fusing to form helium. This process releases a tremendous amount of energy, which pushes outward. This outward push of energy perfectly balances the inward pull of gravity, creating a stable, shining star. Our sun is in this phase right now, known as the main sequence. This is the longest and most stable part of a star's life, where it will spend about 90% of its existence, steadily burning hydrogen into helium. Now, the life of a star is determined by one key factor: its mass. Just like in life, size matters. Let's first talk about average-sized stars, like our sun. For billions of years, they happily fuse hydrogen, but eventually, the hydrogen fuel in the core starts to run out. Without the outward pressure from fusion, gravity begins to win the battle. The core starts to collapse and heat up even more. This extra heat causes the star's outer layers to expand dramatically. The star swells up, becoming hundreds of times its original size, turning into what we call a red giant. Our sun will do this in about 5 billion years, expanding so much it might swallow Mercury, Venus, and possibly even Earth. Inside the red giant's core, the heat and pressure become so intense that a new fusion process begins. Helium starts fusing into carbon. This gives the star a temporary new lease on life. But for a star the size of our sun, this is the last hurrah. The helium fuel eventually runs out too, and it doesn't have enough mass to start fusing carbon. The star becomes unstable. It starts to shed its outer layers, puffing them out into space in beautiful, glowing shells of gas. This breathtaking cosmic structure is called a planetary nebula. Somewhat misleading name, as it has nothing to do with planets. It's the star's final, beautiful sigh. What's left behind at the center of this nebula is the star's collapsed core, a white dwarf. A white dwarf is incredibly dense. Imagine squishing the mass of our entire sun into an object the size of Earth. A single teaspoon of white dwarf material would weigh several tons. This celestial ember no longer produces new heat through fusion. It just slowly cools down over trillions of years, eventually fading into a cold, dark black dwarf, a stellar ghost in the cosmic graveyard. This is the peaceful, quiet end for most stars in the universe. But what about the real heavyweights? The stars that are 8, 10, or even 100 times more massive than our sun. Their lives are much shorter, and their deaths are anything but peaceful. They live fast and die young. Because they are so massive, their gravitational pull is immense. This means the pressure and temperature in their cores are off the charts. They burn through their hydrogen fuel not in billions, but in just a few million years. When their hydrogen runs out, they swell up, but they become red supergiants, colossal stars that would stretch past the orbit of Jupiter if placed in our solar system. In the core of a red supergiant, the fusion process goes into overdrive. After helium fuses into carbon, there's enough mass and pressure to keep the chain reaction going. Carbon fuses into neon, neon into oxygen, oxygen into silicon, and finally, silicon into iron. Each stage happens faster and faster. While fusing lighter elements releases energy, fusing iron actually consumes energy. This is the star's death sentence. The moment the core becomes iron, the energy production stops completely. There is nothing left to fight against gravity. What happens next is one of the most cataclysmic events in the universe. A supernova, in less than a second, the iron core collapses under its own immense gravity. The collapse happens so fast that it bounces back, sending a titanic shockwave blasting out through the star's outer layers. The star is ripped apart in a spectacular explosion, briefly outshining its entire galaxy. This explosion is so powerful that it creates and scatters all the heavy elements: the gold in your jewelry, the calcium in your bones, the oxygen you breathe across the cosmos. Every element heavier than iron was forged in the heart of a supernova. We are, quite literally, made of stardust. The story doesn't even end there. After the supernova, what remains of the star's core depends on its initial mass. If the original star was massive, the core will collapse into a neutron star. This is an object so dense that its protons and electrons have been crushed together to form neutrons. A neutron star is like a city-sized atomic nucleus, so dense that a sugar cube-sized piece would weigh more than all of humanity combined. They often spin rapidly, emitting beams of radiation like a cosmic lighthouse, which we see as But if the original star was a true giant, more than 20 to 25 times the mass of our sun, then nothing can stop the gravitational collapse, not even the laws that govern neutron stars. The core collapses forever, crushing down to an infinitely small point with infinite density, called a singularity. It warps the fabric of space and time around it so intensely that nothing, not even light, can escape its grasp. It becomes a black hole. These mysterious objects are the final, silent remnants of the most massive stars, continuing to shape the galaxies around them. So from a gentle glow in a dusty cloud to a stable star like our sun, to a magnificent red giant, a beautiful planetary nebula, a faint white dwarf, or a violent supernova that forges new elements and leaves behind a neutron star or a black hole. Life of a star is a cycle of creation and destruction. The stardust from dying stars becomes the raw material for new clouds, new planets, and new life. The very atoms that make up you, me, and our entire world were born in the heart of a star that lived and died long ago. The night sky is not just a collection of lights. It's a history book of the universe and a glimpse into our own cosmic origins. Thank you so much for joining me on this stellar journey. If you found this as fascinating as I do, don't forget to hit that like button. Subscribe for more cosmic adventures, and let me know in the comments what you'd like to explore next. Until next time, keep looking up.